Well, dear students, I have started thermodynamics, and I have told you yesterday the concept of temperature, which was derived from zeroth law of thermodynamics. While starting the last chapter, I told you the difference between heat and temperature. Here, now we have to relate heat, work, and energy in thermodynamics. This is very important here. So, heat and work are the form of each other. But there is a fundamental difference between the two. But heat and work are always, they can be converted one from other. We can convert heat into work and work into heat. But there is difference, fundamental difference between them. Both are form of energy. क्या difference है? What is the difference? If energy flows, the energy is transferred from one body to another. One body to another due to temperature difference. Temperature difference. Then the energy transferred is heat. Energy transferred is heat. If energy is transferred from one body to another due to temperature difference, then energy transferred is heat. But if the transfer of energy does not depend on temperature difference. The temperature difference. Then energy transferred is work. Please, dear, this chapter is very important. So you have to understand it basically. I am taking very seriously, and I took throughout my teaching life everything very seriously. Only then we can understand. Now, what is the example of this? For example, if a man is still water, we take some water and stir by any road, then water become hot, and the energy transferred by string the water is work. For example, if a man still some cold water, you can say. Cold in the sense its temperature may be higher than that of man. Depend on the surrounding. Then water becomes food. So the energy transferred by man to water is work. Now this is one simple thing, that just to differentiate between heat and work. Now I will come to work done by thermodynamic system. Work done by, how to calculate the work done by thermodynamic system. And what is thermodynamic system? Work done by a thermodynamic system. Dear learner, dear students, read every topic with cool and calm mind. Don't have any arrogancy or I know this thing, and don't have any hurry. Oh yes, I know it. No, this guy not happening. Learning is very slow process. I keep on telling my students, A for apple is not learned how to make A for apple in first attempt. We have to do many attempts, only then we can write an alphabet. A word. A word is written, and even I have seen a student in class 12 and does not know how to write a letter. Many problems are there. Proper writing, I have seen, is absent from the mind of students because they work their own way. So here, please listen me carefully. Suppose, what is thermodynamic system? First of all, a system whose state can be described by its pressure, volume, and temperature. Pressure, volume, temperature, and mass also is called thermodynamic system. First of all, try to understand this. For example, a certain mass of a gas contained in a cylinder fitted with an airtight insulating cylinder or insulating piston may be treated as a thermodynamic system. I have told you just because this word thermodynamic system will be called again and again while explaining so many things. Then you can keep on thinking what is thermodynamic system. So I told you system whose state can be expressed in terms of pressure, volume, time, mass, etc. Other things are also there, but basically the macroscopic variables which can tell the state are pressure, volume, temperature, mass. Now I come to how to calculate the work done by thermodynamic system. So let here we have a cylinder whose walls are bad conductor. Walls are bad conductor while the bottom is good conductor. Double lines show that walls are bad conductor. A certain mass of gas is enclosed in the cylinder and some weights, the piston here, some weights are placed just to keep the pressure of gas balanced and some ideal gas is filled. Let this A be the edge of piston and P is the pressure. Actually, I told you yesterday thermal equilibrium, and simply I did not tell when a hot body placed in contact of cold body, heat flows from hot to cold, and after some time flow of heat stops and we say that the two are in equilibrium. Yes, they are in equilibrium. This is not the only case. Here I told you that pressure, volume, temperature are variable of system. If they remain pressure, volume, temperature of one system and the pressure, volume and temperature of the system, while they are in the vicinity of each other, or they are in the neighborhood, anyhow they are in contact, does not change, then those systems are in equilibrium. So in equilibrium here, let a gas is filled in a cylinder fitted with airtight and frictionless piston. Frictionless to have to be when one body slides over some energy loss due to friction. We are not considering that. If let capital A be the area of piston and capital P be the pressure of gas. Then the force applied by gas on the piston F equal to PA. Here I have told you that bottom is good conductor, valves and piston are bad conductor. It is because heat come in or come out of the cylinder. I have not written, but you may mention it here. Now, if we reduce the weight placed on piston very slightly. Why I said slightly? So that pressure P of gas or piston on the gas be same, nearly same. But reducing the weight will reduce pressure due to this. Piston will move upwards. Suppose piston moves a distance dx, very small distance here, then work done in pushing the piston by the gas dW equal to F into dx. But F equal to PA, so dW equal to PA into dx. This is the area of piston and move distance dx. Area of base into height volume equal to PdV, where dV equal to A into dx, increase in volume. I have written dV because this is the small change in volume. This is the small change in volume. Now, if the work volume of gas expands from volume V1 to V2. If volume of gas changes from V1 to V2, then work done by the gas is calculated by integrating VW within limits V1 to V2, that is W is equal to their integration dW V1 to V2, or it is integration PdV V1 to V2. If anyhow pressure remain constant, pressure of gas, if however pressure remain constant, if however pressure of gas remains constant, then and volume changes from V1 to V2, then W is equal to work done P bracket V2 minus V1. But fact is that during expansion or compression, certainly volume does not remain constant. When gas expands, there are different methods of expansion and compression. We will be discussing later on. Pressure generally changes. So we will, next video I will tell you, please continue this video in the next, because it becomes very lengthy. So now in next video I will tell you how to calculate work done graphically and what are those parameters on which work done depends. Thank you.